Next one, we want to find the size of the shady area. That's p-value, okay? And how can we find it? In order to use standard normal table, just like before, we need to standardize what? The variable. X bar, subtract by its mean, EV X bar, divided by standard deviation, SE X bar. Any variable, subtract by its average, divided by standard deviation, we get what? Z score, okay? Now, if this is sum box or non-zero one box, EV X bar is just what? Mu is average of the box, okay? And SE X bar is what? Sigma over square root n. Mu is average of the box, average of some box.
Sorry, can't see.
How about now?
Yeah, better.
Average of the box. And what's sigma? Sigma is the standard deviation of the box. Okay? But our example, when we flip the coin, it's count box or sum box? It's what? It's count box, right? So average of the count box is not mu, it's pi. Pi is population percentage. And as I mentioned, there's a formula for what? For count box. That's what? 1 minus 0 square root of pi times 1 minus pi. And then divided by square root of n. And what do you know about pi? This is the situation when this is what? Count box. Or you say what? 0, 1 box. Okay? Count box or 0, 1 box. And what do you know about pi? Well, under H naught is true. It's a fair coin, right? Pi equal to what? 1/2. So you plug in 1/2, plug in n equal to what? 100. You're going to simplify this is x bar minus 1/2. And this is 1/2 times 1/2. You take square root is 1/2 divided by 100. 100 takes square root is 10. So 1/2 divided by 10. This is 1 over what? 20. Okay? So let's standardize this number as well. Okay? Standardize this number as well. 30 out of 100. Subtract by what? 1/2. Divided by 1 over 20. This number convert to what? Convert to minus 2. Okay? So the shady area is a p-value, right? This is a p-value. So p-value, okay, the p-value is just equal to probabilities of z-score less or equal to minus 2. And with z-table, we should be able to find this number, okay? Now let me stop here. You want to copy? Go ahead. I give you 1 minute, okay? Please copy it, and then we're gonna flip to the next page. Try to find you what is a p-value. P-value is z less equal to minus 2, right? Do you finish the copy? Can I move on?
I have done.
Okay, give you I give you what? Give you another 30 seconds, okay? Okay, let's flip to the next page and finish what? This example. So p-value, as I just pointed out, is probability that z-score less or equal to what? -2, okay? So what is that? Look at here. What is 2 here? Huh? 2. What is the corresponding area? 95.45%. Do you read that? Okay. Can you see that? Q
Yeah.
is a z-score, right? And 95.45% is the area, okay? So how are we going to use the table to find the p-value?
It's on left side, so it should be 1 minus 95.45%.
That's very good,
divided by
okay?
Q.
That's right. This is something we covered before. This is 2, this is -2, right? And this is a p-value, right? This is a p-value. And we know from the table the middle part, okay? The middle is what? The middle part is 95.45%, okay? So the p-value should be 1 minus 95.45% divided by 2. So what is that? That's
It's
4.55% divided by 2. And that's 2.778%, roughly. Am I correct? Are we see? And this is very small change when you compare to alpha equal to 5%. Okay? As I mentioned earlier, small p-value lead to the rejection of H naught. When, how small equals small? When p-value less than alpha, we call what? We call significantly small. So step 5. Since p-value, did I recall this one?
I think you got the wrong number.
No, I think I recalled it. Okay, yeah. You see I calculated wrong?
Yeah.
Oh, yeah, that's right. About 2.28, right?
Yeah.
It's about 2.28. Yeah, you are right. I make a calculation mistake. Please change it, okay? This is 2.28. Since p-value is 2.28%, which is smaller than alpha equal to 5%, so we reject H naught. But what is H naught? H naught say this is a failed coin. Reject H naught means what? Huh? We conclude the given coin is what? Is biased. It's not a failed coin. Okay, it's not a failed coin. Are you with me? So let's see. Let's look at this again. Look at the whole thing, right? What's p-value? P-value is when the coin is a failed coin. How likely in 100 flip you're going to see 40 heads or something even more extreme. That chance is only 2.28%. This is a very small chance. That means in 100 flip, you almost impossible to see what? 40 heads or something even more extreme. That chance is very small, almost impossible to see. So when you see it, you will rather believe you see it, not because H naught is true. Because H naught is not true, that's why you see it happens. Is that clear? So that's why small p-value lead to the rejection of what? Of H0. Okay? Let me try one more time. What's p-value? Under H0 is true, how likely test statistic behave at least or even more extreme than observed value? Well, in our case, let me rephrase it. In our case, if this is a fair coin, how likely in 100 flip you see 40 heads or something what? Even more extreme. The chance is very small, 2.28%. Almost, that means almost impossible to see this happen. So when you see this happen, you will rather believe you see this happen, not because what? H0 is true. Because H0 is true, this one has very small chance to happen. So when you see this happen, you will rather believe you see it, not because H0 is true, because H0 is not true. So that's why small p-value lead to the rejection of H0. Is that clear? And how small you call it small? Well, alpha less than what? The p-value less than alpha equal to 5%. We say it is what? Significantly small. Are you with me?
Yes.
So small p-value. Lead to the rejection of what? Of H0. Okay? And this concludes our lecture what? Our lecture here today. Okay? And I want to talk, don't go, okay? I think I recorded, okay? I think I recorded.